So I'll talk a little bit about why we believe the low-code really has a lot of help in the AI area. I obviously have an agenda. We'll talk a little bit of low-code, how genAI fits into that one, obviously also how Databricks and Knime work together. And then I'll have a bit of a peek into the future where we think, and I'll hopefully also give you a little bit of a background, who Knime is, what we do, and that we're reasonably serious. We'll see. And then ideally we have time for questions afterwards. We do have a booth all the way on the other end, 103. So if you want to have more conversations, deeper dive demos, Jeff here does phenomenal demos. We are around until 5. I don't know about you. Good. Low code for data science. To me, it's important to there's a big difference between how different people look at that. Typically, a lot of the other software vendors that you see here, and that's not a good or bad kind of categorization, it's just a different way of looking at low code, essentially have visual bits and pieces. Sometimes it's just a wizard that creates code. Sometimes it's an interactive tool that modifies code. But fundamentally, at the end of the day, what you get is code, right? And often, very, very often, at the end of the day, when you want to kind of twist little knobs and do something, you actually are expected to reach inside this code. A lot of those things obviously sitting on top of Python, but also here, of course, lots of things sitting on top of SQL. I don't think we have that many in this audience that are doing that on R, but those tools, of course, exist as well. Sometimes it's also a mix of SQL and Python, but fundamentally, underneath the hood, there's code. What we do on Knime side is a visual workflow. So the visual workflow is the program. What you do there is what runs underneath the hood. And I'll show a couple of examples of that later. Obviously, we're not programming all of this stuff ourselves. And obviously, it's written in some sort of a language underneath the hood. We're writing a lot of these nodes, the workflow engine in Java and Python. But we are also reaching out to C, we're reaching out to R, we're reaching out to JavaScript for a lot of that functionality. And as part of the workflows, I show examples of that as well. If you want to, you can reach out to code. That's why some of these errors are bidirectional. Yes, we are reaching out to Python libraries. You don't need to care about it. But if you want, you can also make Python, a little piece of Python code, part of your workflow. Same is true with R, Python, some of the other things. We do, for example, not have this type of support for C, right? There's no way to embed C snippet. We don't see a need for that. We could do that if somebody asked for it, but so far nobody came. But Java, SQL, R, Python, JavaScript are all things that you can reach out to. So fundamentally, it looks like this. You don't need to care about all of the details. Fundamentally, it's a visual workflow that you put together in an editor. That's a Knime workflow. And it models what you want to do with your data. So it really models the workflow. And again, we can't really translate this into Python or something because this is the program. So the workflow engine will execute this. Underneath is, of course, a textual representation in JSON files that tells you which nodes are connected with which other nodes and what the configurations are. But this is what runs. In contrast to many others here, we are not only focusing on the data access transformation piece, but we also have quite a lot of functionality actually, around the analytics, around the data mining, the visualization piece. So you can create sophisticated models, you can train all of the classics, decision tree, random forest, all of that type of stuff. And of course, underneath the hood, again, right, for random forest, XGBoost, fantastic library. We're just using that library. We're wrapping around that library. All of this stuff's open source. And then, of course, deployment, right? You can deploy this as a REST service. You can deploy this as a web app that runs in your browser. You can deploy this. You can write reports automatically, or you can write data back into databases, whatever. The interesting part, as I said, underneath the hood, we are, of course, relying on a lot of other technologies. On the connector side, you can connect to many, many different databases. You obviously, here I'm showing examples with Databricks and Spark, but not surprisingly, we, of course, also have connectors that allow you to connect to other execution environments. I believe they had a conference here last week, but anyway, you get the idea. And then in the middle part for the analytics, for the mining, you can reach out to OpenAI. I'll show a couple of examples there, but you can also reach out to R, JavaScript. We have some of those are our own implementations. Some rely on Python, on R, or on some other implementations. And then on the deployment side, we use tons of databases as well, right? So that's fundamentally the idea that you as a data scientist who wants to model the data flow, you don't necessarily need to care about which technology runs underneath the hood all the time. We look at data science this way. that's not too surprising. On one side, you have the creation, right? You're building cool, optimizing cool workflow models. On the other side, you somehow need to make sure you're not stuck with a great report or a great model, but you actually also have a mechanism to move this into production so people actually use it and do something with it. This looks suspiciously like a typical CI/CD from software development, and many, many instances of that are similar. However, there are two key differences here. One of the big differences is that what you build on the creation side is not what you move into production, right? Because software engineering, you build an application and you put that application in production, but in data science, you're building something that optimizes parameters, trains a model, does all sorts of stuff, but something else goes in production. The model, ideally together with the transformations that you need, goes into production. That's what we call production process. And Knime can actually do that. As part of that workflow, you can grab the transformation and the model that you just trained and move that automatically in production. And then on the production side, the typical stuff, right? You need validation mechanisms, deployment mechanisms. You need ways for people, your users, the ones that actually make use of that, to interact with that. And then on the monitoring, updating side, that's the other key difference to software. In software, the monitoring essentially says, well, make sure the application runs, right? And didn't crash overnight and then restart it. In data science, you need to make sure that the model that you just deployed is still meaningful a day, 2 days later, right? So you need to constantly check for drift, changes in the model, changes in reality, and then potentially do something. Update the model, retrain the model, alert your data science team, hey, this is totally out of whack, doesn't work anymore, we need to do something. We have two pieces of software. Unfortunately, you can't see this all, but it doesn't matter that much. Underneath the creation side, that's the open source platform. It's like a designer that allows you to build workflows, execute workflows, tons of extensions for geospatial analytics, for text mining. You can even, if you want, you can plug molecules in there. We have type support for that as well, documents, all sorts of stuff. All of that, open source and free, right? Anybody can use that, download it, go to our website, download it, or see a demo later over there. And then on the production side, we have what we call the Knime Business Hub that gives you all of that enterprise functionality. You want all of these individual workflow designers to collaborate with each other. You want to version that. You need mechanisms to put it into production as a REST service, as a web application. Those types of functionalities are part of the Knime Business Hub. The little box there in the bottom, the Knime Community Hub, is our business hub that we as Knime are hosting for everybody, for our community, right? We have a community of about 500,000 workflow developers. They are sharing workflows there publicly, right? That's a really nice treasure trove to go in and find examples for tons of different types of things. Obviously, you can't see that at all, but down here I'm circling the AI governance. Of course, here is the big topic. You can't have a talk these days without saying AI. Of course, the hub also gives you quite a bit of governance features, right? Where you can say, I want to make sure all of these workflow creators, we have connectors to everything. That's one of the strengths of Knime. But maybe you don't want everybody in your organization to connect to OpenAI and Azure or whatever, some AI hosted by your competitor, right? So we can limit what kind of functionality is available in these analytics platforms. And we can also make sure that the AI wizards, the co-pilots that we have as part of the workflow creation, I'll show an example of that in a second, also get funneled to a compliance-approved AI, right? So on the business hub side, essentially you configure, well, marketing is allowed to use OpenAI, finance isn't, they have to go to this type of AI, but whatever your compliance officer dreams of, right? That's, we can make sure the data science team adheres to these guidelines nicely. Okay, so genAI and Knime, this essentially, obviously we have all of these built-in capabilities that make it easier to build data science. I'll show an example of that in a second. But of course, we also have embeddings, extensions that allow you with Knime nodes to reach out to all sorts of AI stuff, right? Mosaic AI that was discussed 2 days ago. There's obviously quite a bit of stuff around these compound AI models. We'll keep adding functionality here so they can use that without touching code from that visual workflow interface as well, right? So the genAI extensions, this is already outdated. The screenshot is from, I don't know, 3 weeks ago when we had to submit the slides. There are already new nodes that we added to this one. It's something that's constantly growing. There's also community helping there quite a bit. So a workflow that you use could do all sorts of stuff. In a sense, you're augmenting the analytics work that you've done in the past with genAI functionality. But you can also use this to customize genAI functionality, for instance, here by creating a vector store. So you build a RAG at the end of the day in Knime. It's not terribly interesting because there are others out there that can do that anyway, but this is type of functionality that we have. And then, of course, you can also use it to safeguard. You can make sure that before my data gets sent to whatever, OpenAI, it gets anonymized and then I de-anonymize when it comes back. So that type of functionality is very easy to model as part of a Knime workflow too. This is 2 examples of how we are using on the workflow creator side AI to make it easier for people, right? I mentioned this before, you can open the dialog on the Python scripting node and then there you write Python code, right? And we now have AI support there as well. So you can ask that, like, write Python code for da-da-da. We do the same also for visualizations, for e-charts. We have an expression node that now has AI support, and we keep adding to that functionality, of course. That's an obvious thing to do. It's essentially building co-pilots. Knime itself, on the workflow creation side, also has a co-pilot that you can ask to build pieces of a workflow or just to help you with building a workflow, which honestly, the building a workflow is a bit of a gadget to me, but the help is super cool, right? You have spreadsheet users or Python programmers coming saying, hey, I'm used to doing it this and this way in Python or spreadsheets or Excel macros. How do we do this in Knime? Da-da-da. Here are the 4 nodes that you want to use. Happy to show you a demo later over there. Booth 103 for those of you who come late. Databricks, Knime, same story. So this is not yet the Databricks slide. I have that, that's the next one. This is just to illustrate how data transformation, data wrangling can look in a Knime workflow. And up here, the little animation shows you how easy it is to flip from one cloud provider to another cloud provider, right? The logic, all of the data science IP that your team built over the years stays intact. All you need to change is the connectors at the beginning, right? So you got tired of Amazon, switching over to Microsoft, same story. And this workflow also tells you a little bit what it's doing. That's the other nice piece, right? Even if not everybody is a Python programmer or an R programmer or a SQL programmer, I think reading through that one, if I gave you 5 minutes, you would understand what this workflow does, even if you're not a technology geek. So it also, this way of collaborating between the data engineers and the machine learning engineers and the visualization geeks makes that type of collaboration a lot easier. And this is the Databricks example, right? So we have down there, Databricks environment, you connect to that, you get the idea. And what's also important here to see is we're not instantly pulling everything to the workflow and handling the data there. But at this part, the first part of this workflow, just orchestrates what happens in the Databricks environment, right? And adding a couple more nodes to this one so that we can also reach out to Mosaic AI, fairly easy to do. Actually, Mosaic AI, you can already connect to it now, but for this compound AI and adding agents to the mix, we'll probably add a couple of nodes, and then you can do that from a workflow as well. So to me, if I kind of look back at this graph where I showed, well, there's low code and underneath there's a bit of code-based programming. That's in a way how Knime works. You kind of start to wonder how genAI will impact that, right? And there's, of course, something, these co-pilots, I think they will take away a lot of the need to actually ever reach out to code. For e-charts, the visualization stuff, that works phenomenally well already now in Knime. I mean, you have almost no need to ever reach into e-chart configurations. The interactivity works great. On the Python side, I tried that a couple of weeks ago. You still get into arguments with the co-pilot from time to time, and at some point in time, you're just like, okay, I'll do it myself, and you reach in. But I think there's huge potential there that might turn this type of low-code setup even in a completely no-code. We'll see. That's one claim for the future. The more interesting part is, of course, that all of these genAI workflow assistants, together with those co-pilots, of course, allow people to get started much faster, get a lot of the boring stuff much faster, and then hopefully they'll have now time left to do even cooler stuff inside these Knime workflows. We'll see where that goes. Okay, so to throw together, I have 3 slides just for, since nobody here knows Knime, just to give you a bit of an impression who we are. These are customers in various different domains. We have Knime has about 250 employees. We have about 400 customers. They're paying us money for the business hub. We have about 500,000 people using it across the world. This 500,000 of people using it across the world, often in commercial institutions, actually provide use cases across the entire board. Sometimes people come to us and we look at what they're doing with Knime, we're saying, whoa, this is weird, very wild. So we learn a lot of stuff there. So just as this one. The really interesting part, again, is the Knime community hub. You can go there, hub.knime.com, and search for everything from how do I build a decision tree? Okay, here are the 4 nodes that you need, to how do I build a churn prediction model? It's also there. How do I do text mining? How do I do this and that? So this is pretty cool. Also has collections for specific themes, for specific topics that you can look at. This one is a marketing slide, obviously. I'm not a marketeer, but essentially says there's money savings, time savings, other types of savings. There are customers. We have use cases on the website. You can check those out. And then, of course, we have customer quotes. Anyway, I'll skip over this one because to me, my summary is essentially a data science team shouldn't really worry about what a library does, what technology that library is written in, what programming language that's written is, how do I interface those, how do I get all of that stuff together. But they should worry about what they want to do with the data. Because at the end of the day, for data scientists, they need to know what these methods do, right? What does a regression line actually mean? They don't necessarily need to know how I do find the coefficients for that regression line, right? If you don't understand what the method does, you should not be using it, right? Because all of your interpretation, all of the conclusions you draw from that are going to be not very good, let's put it mildly, right? So that's enough to know already because there's this wild mess of methods out there, many methods to know, and we'd rather have people focus on the data flow, understand what the methods do, but can ignore the interfaces between technologies and the actual implementation. And with that, I have a few minutes left, but I think with this small crowd, we can just do QA interactively. Thank you all for coming.